A radio signal from 8 billion years ago has been recorded. Astronomers have found the most distant fast radio burst, FRB, to date. It was emitted in a galaxy as many as 8 billion light-years away from us. The signal, designated FRB 20,220,610A, is also one of the most energetic ever observed. In a split second, it released the energy emitted by the Sun for about 30 years. Astronomers have detected an FRB signal from a galaxy as far as 8 billion light-years away. The signal marked as FRB 2022061A is the oldest signal of this type recorded. Before reaching Earth, it traveled across the vastness of the universe for 8 billion years. It is also one of the most energetic. In a few milliseconds, its source emitted the equivalent of energy that the Sun produces in about 30 years. Scientists still don't fully understand what FRBs actually are. Some of them are disposable. Others appear cyclically from the same point in the sky. The biggest surprise about FRB 2022061A is its age. We didn't know that FRBs even existed that long ago, said Stuart Ryder of Macquarie University in Sydney, Australia. The results and description of the research were published in the magazine, Science. Fast radio bursts are millisecond-long bursts of radiation recorded at radio waves. They are extremely energetic, but the short duration of these phenomena makes their study much more difficult. The first FRB was discovered in 2007 by Duncan Lorimer and David Narkovich. Since then, many other FRBs have been detected, coming from almost all directions in the sky. Most of them were single, one-off signals, in the sense that they came from different sources. But several of them turned out to come from the same point in the sky. The cause of fast radio bursts remains unknown. But since the first detection of FRBs, several hypotheses have arisen about the mysterious signals. One says that they come from a rotating neutron star. Another is that their source is cosmic cataclysms, such as supernova explosions or the collapse of neutron stars into black holes. Yet another points to theoretical astronomical objects called blitzes as the source of FRBs. A blitzer is a type of neutron star that is massive enough to collapse into a black hole, but is prevented from doing so by the centrifugal force from the star's high spin speed. Another concept focuses on the so-called contact binary systems, i.e., two stars orbiting very close to each other. These repeating FRBs appear to originate from extremely magnetic neutron stars orbiting other objects, periodically interacting with the plasma around them, unleashing huge bursts of energy in radio waves in quick succession. There is also no shortage of supporters of the claim that these are signals from an extraterrestrial civilization. The FRB 2022061A signal was discovered in June last year by astronomers from Australia. They detected it using the ASKAP, Australian Square Kilometre Array Pathfinder, radio telescope. They then used the European Southern Observatory's Very Large Telescope in Chile and the W.M. Keck Observatory in Hawaii to locate the galaxy it came from. Researchers determined that this galaxy is the oldest and lies further away than the sources of other FRBs recorded so far. When researchers used telescopes to check the place where FRB 20220610A came to us, they discovered that it is probably not one galaxy, but a cluster of several galaxies. This suggests that the FRB may have been formed by collisions between galaxies. Determining the source of FRBs is a major achievement. So far, only about 50 FRBs have had their source found. This could help astronomers better characterize these phenomena. They can also be used for research on a completely different issue. As fast radio bursts travel through and between galaxies, they pass through hot gas, which causes low-frequency radio waves to slow down more than higher-frequency ones, a phenomenon known as dispersion. This means that radio waves of different frequencies reach telescopes on Earth at different times, allowing scientists to infer the presence of material that is too hot and diffuse for other types of telescopes to directly detect. If we count the amount of normal matter in the universe, the atoms that make up all of us, we find that more than half of what should be there is missing, said Ryan Shannon. We think the missing material lies in the space between the galaxies, but it may be so hot and diffuse that it cannot be seen using normal techniques. Fast radio bursts detect this ionized material. Even in almost perfectly empty space, they can see all the electrons, which allows us to measure how much matter is between galaxies, he added. FRBs are therefore useful cosmological tools for analyzing the universe because they allow scientists to detect and measure material lying between galaxies that is currently invisible to us. FRB 20,220,610A's signal was more diffuse than most previous ones, suggesting it has had a bumpy ride during its 8 billion-year journey. The extremely scattered signal and the enormous distance from the host galaxy also confirmed what previous studies of nearby FRBs had suggested: the further away they are, the more scattered their signals will be when they reach Earth. This signal was also powerful, emitting 3.5 times more energy than the maximum amount predicted by existing models. While we still don't know what causes these powerful bursts of energy, it seems clear that FRBs are a common phenomenon in space and that we will be able to use them to detect material between galaxies and better understand the structure of the universe, Shannon says.